So, hello my dear students. So, how you are feeling now? So, I just want to ask a few of you, not few of you, all of you, whoever has joined, what is your current situation? Means, are you confident enough, or you can trust this channel or not? Whatever I have predicted, if it came for your examination or not, just let me know. Whoever has watched my long video for the physical and inorganic, for organic, did you get common out of it? Okay, I can see it was easy as hell. Very good, very good. Easy, ma'am. Okay, very good. Compared to last year, was the paper was easy or tough? Definitely it's going to be easy, super easy. So what I found, a numerical, not numerical, sorry, this MCQ zone, a little 2 or 3 questions was a little bit out of track, right? But those things, you know, if you can predict, if you can guess those things, you will get to understand actually. Okay, so yeah, let's go ahead with the answers. Okay, anyone is there who is feeling that they are not confident, they are not getting enough support from me? Yes, any one of you? Okay, so let's go ahead. So first I want you people to answer me. So please answer me so that I can answer, I can understand that how much I actually helped you people. So I can see that 138 people out there and they have trusted our channel, and yes, that's the reason I'm again staying here after doing the live at 4 AM for you people. So yeah, let's go ahead with the first question. You will tell me the answer or I will tell? Okay, so the first answer is 2-butene, right? So many times I told you it will follow the Saidzev rule, right? So yeah, I guess it's fine. Let's go ahead with the next question. Okay, now you will tell me the answer. So basically for this case, I told you what is, we've told multiple times what is bend, and then only I told you what is the percentage of helium. Whoever has done the physical chemistry class, they must have known this. This is basically, what is the answer? Tell me. The answer is going to be 11.7, right? Okay, let's go ahead. Next, so many times we have repeated this question, right? So many times, that's going to be +3. Okay, let's go ahead. Super excited students. I can see our super excited student. Okay. So if you really get a little bit of benefits from my channel, from our teaching, so please don't forget to like the channel, and I mean to say subscribe the channel and like my video, because you motivated me a lot to stand for a longer period of time. Yes. So yeah, let's go ahead for the next question. Main natural source of acetic acid, I don't think that I have to tell you this, it's going to be vinegar. Okay, so let's go ahead. Keep answering. Okay, keep answering. Acetylation of salicylic acid. So many times I have repeated. Okay, I have to go fast. You are so confident about it. Okay, so this is going to be aspirin, right? Okay, very good. Let's go ahead. Para-hydroxyazobenzene. So this particular reaction is going to be what type of thing? This is basically electrophilic substitution or not? What? Tell me this answer. Okay, that's going to be electrophilic substitution. If anyone is having any doubt why it is an electrophilic substitution, then you can comment me below. I can explain that as well. Okay, no, it's not an hydrogenation reaction. Basically, whenever it gets coupled up, it forms N2+ that works as an electrophile. Okay, let's go ahead. Here you can see it's a model paper question. So many times I have done this thing. It is going to be which one? Answer me fast. It's going to be vitamin D. Okay, let's go first. Which of the following statement is or are incorrect about the order and molecularity of the chemical reaction? So the probability that more than 3 molecules can collide and react simultaneously is very small, so that's going to be correct. There can be only 3 values of the order of the reaction, that is 0, first and second. That's going to be a wrong one, right? So this is a wrong one. Another one, the order depends on the rate equation while molecularity does not. That is true. Next, there can be infinite number of values of order, so that's also going to be wrong. So 2 and 4, so option C is the correct one. Very good, very good. Let's go ahead. So which of the following groups when present in para position increases the basicity of basic strength of aniline? That is electron donating group, that is NH2, right? Very good. Okay, let's go ahead, we are going really fast. Okay, someone is saying it is the D. No, there cannot be infinite value of orders. There should be a limited value of the orders for a particular reaction, right? So let's go ahead. Next, here you can see among the following cells, the cell that is used in the Apollo space program for providing the electric power, that is H2O2 fuel cell, right? Let's go ahead. Isopropyl magnesium bromide and N-propyl magnesium bromide. So isopropyl magnesium bromide, if you just draw, it is basically this, right? So MgBr, right? So for this case, if you treat this with water, you will get this type of system, this, right? So this is what? This is CH3, CH2, CH3. So this is also going to be propane. And the second one, if you are having N-propyl bromide, C, MgBr, right? MgBr. Here also if you give H2O, then also you will get the propane. The same system you will end up with. So it's going to be propane and propane. Okay. So option D is going to be the correct one. I guess this is clear. Let's go ahead. Here you can see binary solution has 2 component A and B. Mole fraction of component A is 0.5. Then the number of moles of component A and B in the solution, they are going to be option C, right? Yeah, let's go ahead. Okay, this is quite confusing, but let me tell you how to predict it. Even if you ask me suddenly what is the oxidation state of lawrencium, I don't know it. Okay, so now let me tell you, my dear, for plutonium, neptunium and plutonium, they are basically actinoids, right? And they have +7 oxidation state. Okay, so this is something that I know. So it is going to be A. Okay, another thing, thorium always shows +4 oxidation state. Right? It always shows +4 oxidation state. Or you can go for 3. Lawrencium always shows +3 oxidation state because it is an lanthanides. Right? So, with respect to that, if you mark it as E, you already got your answer, I guess. Yes. If you start 1 with E and 5 with A, option B is the correct one. Okay, let's go ahead. Here you can see this is also out of track question. I understand this is also out of track question, but the coloration, whenever the linkage isomer will be changed, the color you will get yellow. Okay, this is something that you have to remember. Definitely it is something that remember, like you have to by heart. Otherwise there is no way to understand this, the coloration. Okay, let's go ahead. Okay, so given below are 2 statements. Alcohols are acidic in nature. The acidic character of the alcohol is due to the polar nature. The polar nature of OH bond in it. Okay, and alcohols are weaker acid than that of the water. So definitely both of them are going to be true. So option 1 and option 2, both of them are correct. Option B is the correct one. Right? Let's go ahead. Okay, oxidation state of nickel. Who will tell me this thing? Oxidation state of nickel. Fast. Tell me the answer. Who will tell me the answer of this question? 16. Okay, that's going to be 0 by Bhargavi. Okay, that's going to be 0. Very good. In Williamson ether synthesis, the alkyl halide is allowed to react with what? Sodium alkoxide, right? Sodium alkoxide. Okay, next the carbohydrate which reduce Felling solution and Tollens reagents are called as reducing sugar, right? They are called as reducing sugar. The lower aldehyde have sharp what? Pungent or pleasant odor? Tell me. Lower aldehydes they have pungent or lower aldehydes they have sharp, pungent or pleasant? What do you think? Pungent, very good. As you will move forward, as you will move towards a higher order aldehyde, they will give you the pleasant order. Van't-Hoff factor I for non-electrolyte solution is going to be 1. Okay, so let's go ahead. Okay, answer why. I don't think that I have to explain this thing again and again. What is a transition element? Give an example. D to D transition can be done for those cases. Okay, so let's go ahead. Right, SN2 mechanism of chloromethane and methanol, last day itself we did it, in the morning itself we did it, right? So for chloromethane I don't think that we have to go ahead with the mechanism right now. I guess you could do it. Okay, SN2 mechanism. What is the half-life of a reaction? Represent it symbolically. Did you have any problem with this? Let's go ahead. Here you can see list any two nitrogenous base commonly found in both DNA and RNA. Who will tell me the answer for this case? Any two nitrogen base commonly found in DNA and RNA. So adenine, basically adenine can be found in both the cases. Guanine also can be found in both the cases, right? Adenine, guanine can be found in both the cases. Even cytosine can be found in both the cases. But thiamine is present in DNA and uracil is present in RNA. That's it. Let's go ahead, write the products form when anisole reacts with ethanoyl chloride. Same question we did last day in organic class. So if you are having anisole, that is OCH3, if it reacts with ethanoyl chloride, that is CH3, CH2, CO, Cl, ethanoyl chloride, then you will end up with ortho and para substitution, right? OCH3, here you will be having CO, C2H5, another one what you will go get, here you are having OCH3 and here you will be having CO, C2H5. Okay, let's go ahead. Okay, using valence bond theory, multiple time I told you this question, even in the morning, last day, paper predictor session, everywhere I told you this thing. I guess you didn't have any problem related to it. The hybridization was basically D2sp3, right? And the geometry was octahedral and the magnetic property was diamagnetic, right? Let's go. What is lanthanide contraction? Mentioned in it, two consequences of it. I don't think that I have to tell you, multiple times I told. Okay, let's go ahead. Here, this particular compound in the form of oxalate, I did it multiple times. So basically, for this case, you will see first cis and trans, and cis is optically active. So for this case, let me just draw the thing at first. So L is the bidentate ligand. So you can draw it like this. Here your X, here your X. This is your trans. If I want to draw the cis, it will be something like, if I want to draw the cis, M, this. So if I want to draw the cis, here let's write L, here let's write L. This is your X, this is your X, okay? Now let's make the isomer. I mean, this is, let's say D, another one is L. If I want to write them, so L, okay, here L, okay, here you can see X, X. This is D, this is L. I guess this is clear for you. Let's go ahead. Okay. So for this case, who will tell me the answer? So that is definitely going to be your chromite. Okay. For this case, it is going to be your H2SO4. For this case, definitely it is going to be K2Cr2O7. Okay. Let's go ahead. IUPAC name of the structure. So that is going to be, how many carbonyls are there? Octacarbonyl. How many cobalt? Dicobalt. then 0. Same problem we did it. If you just draw the structure, cobalt bond, C double bond O, 2 bridging ligands are there, okay. Rest of them are terminated ligand, right? C double bond O, here also C double bond. Just let me write CO, it will be easier, okay. So that's going to be your that's going to be your CO, here also CO, here also CO, 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 CO. So I am having 2 bridging ligand, right? C double bond O, here also C double bond O. Okay, I guess this is okay, 2 bridging ligand. Next, let's going ahead. Okay, derive integrated rate equation for the first order reaction. I don't think that we have a problem because from the morning session it is, I directly did this derivation over there as well and it came. Okay, let's go ahead. No, if you have missed that oxidation state, you won't get the full marks. Okay, oxidation state for the metal, I told you in the mistake, I made a small short that what mistake you need to avoid. There also I told oxidation state is something that you must mention. Okay, so yeah. Now paper was not medium, paper was super easy basically. Okay, anyone can get out marks. Okay, so you can see next question we can go with the SHE, that also multiple times I told you, theoretical question with the diagram you can go ahead along with the half cell reaction, right? Let's go. What is ideal solution? Direct question they gave. Okay, so don't you expect that like it is way too easy question. They are not even asking for the difference, they are directly asking what is ideal solution, give 2 characteristics of it. Okay, so yeah, let's going ahead. Mention any 3 factors which decides the products of electrolysis, that also I discussed. I gave a chart. Okay, so different factors that can be that can what the factors actually that depends upon the electrolysis. Okay, so the product it depends upon the nature of the electrolytes, the medium that you are using and the electrodes. This thing if you give, it will be more than enough. Let's go. Name the 2 monosaccharides obtained when glucose is subject to hydrolysis. What you wrote? That's going to be alpha D glucose and beta D galactose, right? Alpha D glucose and beta D galactose. Do you really think that they didn't ask any Haworth projection? I thought that lactose and maltose they will ask, but they are asking what are the monosaccharide you will get. They are not asking you to draw it. Okay, so how much easier you need? That's going to be super easy, right? What are non-essential amino acid? I guess you know this. The non-essential amino acid means they get synthesized in your body, right? And the optically active is optically inactive, that is basically the glycine. Next, named hormone which mediates the responses to external stimuli, that's going to be epinephrine or adrenaline. Okay, so let's go. When alkyl chloride react with sodium iodide in dry acetone, so for this case it is a Finkelstein reaction. Role of dry acetone, it is to make the reaction towards forward direction. Okay, so let me just solve the paper, then I will come to the comment section. Whoever is commenting, I will answer them. Okay, someone is saying 25 question, I will go back there and I will check. Okay, what is meant by racemic modification? They are optically inactive. Why? Racemic modification means, I guess you know that racemic mixture, that after the SN1 reaction you will get the equimolar mixture of D and L, right? That is called racemic modification. And why they are optically inactive? Because they used to cancel out their optical activity, right? That's why they are optically inactive, right? Let's go ahead. Write the chemical equation involved in preparation. So many times we did Gabriel thalamide synthesis. I am not going for the detailed, diagram. Illustrate the carbylamine reaction. Direct question from amines. I told you, if you are planning to skip any chapter, you can go for the amines, and few questions only, 3 to 5 questions I told you, those only you study. These are those questions. Okay, direct question. Let's go ahead. Direct question, as you can see, I told you. This is a direct question. Here you can see this mechanism, I guess so many times we did. Last class we did, morning we did. Okay, so here this question is going to be benzoquinone, right? Last day we did, and for this case it's going to be all the bromine you substitute here, Br, and here I am going to put OH, right? Let's go ahead. Okay, this type of question. Let's go ahead with the problem. C3H4, right? It is propyne. No other options are there. C3H4, it is propyne. It's a very easy question they gave actually. If you have tried, please comment me if you have tried this question. Okay, so C3H4, if you draw CH3, CH, triple bond, CH. There are no other possibility for C3H4, trust me. Okay, in the presence of sulfuric acid and mercury, that is oxymercuration, demercuration. That is oxymercuration, demercuration, right? H plus in presence of Hg2 plus. Okay, so I told you this reaction as well. It will form the OH at first. See, here I will get OH, double bond. Here I will get CH2, but it undergoes ketoenol tautomerism, right? That also I told you in the organic session. CH3, C double bond O, CH3, right? It will, this is your A. This is your A, right? Now, for this case, you are having a methyl keto unit, right? COCH3 is a methyl keto unit. There you are giving sodium hypoiodide, means iodoform reaction you are performing, NaOI, methyl keto unit, so definitely they will participate. So you will end up with CH3COO minus plus CHI3. This is the yellow precipitation you will get. Okay, sodium hypoiodide give, this is my B, this is my C. Okay, when A is heated, let's come back to A. Okay, A is acetone, right? So let's come back to A. CH3COCH3. This is my A, right? This is my A. Okay, I wrote. Now, if you see where I was, if A is heated with barium hydroxide catalyst, it forms D by readily loss of water. Okay, you know what reaction will be taking place here? Barium hydroxide, it's a concentrated it's a diluted acid basically. Okay, barium hydroxide, it is a basically diluted acid. It will follow aldol condensation reaction here. Okay, so let me do the aldol condensation. CH3, CO, CH3. I told you how to do it even last day. So I am having CH, H, H here, CO, CH3, right? What I told, this oxygen will takes up this hydrogen, right? And this carbon make a bond. So I will get CH3 whole twice. This carbon I will get oxygen with hydrogen, and let's this carbon and this carbon, if I make the bond, I will get CH, here I will get CH2, here I will get CO, CH3, right? This is the thing I will get. Okay, so now what I will do? Here I will do the heat, I will give heat. Okay, if I just heat it, I will get alpha beta unsaturated ketone, right? In this particular position, I will get the double bond. So let's do C with CH3 whole twice, okay? Along with that, double bond CH, C double bond O, CH3. Okay, so that's going to be, here you can see readily lost water to give you C, right? To give you C. So you can see, I guess this is clear for you. Upon heating with sodium hydroxide and calcium chloride in the ratio 3:1, give one compound E. So up to this it is clear, I guess. Readily lost one water, right? Up to this it is clear, right? Next, if I, this is my D basically. This is going to be my D. Next, what it is saying, if I am having the C, CHI3, upon heating with sodium hydroxide and calcium oxide in the ratio 3:1 gives your organic compound E. So yeah, let's go ahead. If you further go ahead with E, then basically CH3CO minus, let's make it, do one thing, let's make this B and let's make that C. This is my C, this is my B, because from here it will not react, from C it can react. Okay, so further if I just go ahead, here I am showing you CH3COH, right? CH3 COONA you will get, right? CH3CONA. If I further treat this with sodium hydroxide, NaOH and calcium chloride, in presence of calcium chloride. So what will happen? Decarboxylation will take place. Okay, decarboxylation will take place and you will end up with methane. Okay, plus Na2CO3, plus Na2CO3. You will end up with methane basically. This methane is your compound E. Okay, I guess it is clear to you how you should answer this question. First, start with the propyne. Propyne in presence of oxymercuration, demercuration, it will give you the acetone. Acetone on being treated with NaOI, sodium hypoiodide, it will give you this carboxylate salt, O minus Na plus, and that bromoform or iodoform, sorry. It will give you the iodoform, right? So this iodoform, let it be B, and this particular compound make it C, because from here NaOH will react. With this NaOH will not react. Fine. So now what they are saying further, this A further reacts in presence of barium hydroxide, it will undergo aldol condensation. Okay. Aldol condensation, if you go ahead, you will get this compound as D. Okay. Now they are further saying C in presence of sodium hydroxide and calcium chloride. Okay. Now they will give you compound E. Right. So this is basically methane. Decarboxylation will take place. You will get methane. So A, B, C, here D, here E. I guess it is clear for you. Let's go ahead. Okay. HBZ reaction I am not going further. Write the chemical reaction for the conversion of toluene to benzaldehyde. This is basically ATAD reaction, right? Next, name the gas used to facilitate the nucleophilic addition. This is also I covered in the organic chemistry. So that is basically dry HCl gas. Okay. Next. Okay, so numerical problem, common numerical problem from the 50 top numerical problem we already did. So let's go ahead with the numerical problem. Okay, so first what we have to do for this case, so I can use the formula P naught minus P divided by P is basically x of 2, right? So from here if I just put the value, I need basically the N2 value. So N2 value is how much? If I calculate for the C8H18, it will come up to be 114 gram per mole, right? We did it. So now given is 114 gram divided by 114 gram per mole, right? So from here I will get 1 mole. Okay. 1 mole. Okay, so X2 now I will split in the form of N2 divided by N1 plus N2. N1 I need, sorry, N1 I will get here. Fine. Now let's put the value here. P naught is basically minus of 80% of P naught, right, divided by P. Okay, so now if you further go ahead, sorry, P naught. Now if you further go ahead, if you put the value, I have to calculate the N2, right? N2 divided by 1 plus N2. Okay, so from there if I just go ahead, P naught minus 0.8 of P naught by P naught is basically equals to N2 by 1 plus N2. Okay, from here I will get 0.2 here. 0.2 is basically equals to N2 by 1 plus N2. Okay, so from here 0.2 plus 0.2 into N2 equals to N2. From here what I am getting, 0.2 is basically equals to 0.8 of N2. Right? So from there N2 I will get it as 0.2 divided by 0.8. Okay, so N2 you will get it as 0.25 mole. Okay, I guess up to this you understood. Next what I have to do, I have to find out the weight. So weight it is going to be number of moles N2 into the molecular weight, that is given 40 gram, right? So 40 gram per mole. Okay, so this is going to be 0.25. So 0.25 into 40 gram per mole, this is mole, mole will be cancelled out. Okay, so from here you will get 10 gram as an answer. Okay, without calculator you can go ahead with the problem. Okay, you don't even need the calculator for this perspective. Okay, I guess this is clear. You will get the what is the answer for this question. You are going to get 10 gram out of it. Okay, just comment me below how many of you have done correctly this problem. Let's go ahead. Okay, this is out of syllabus problem, but super easy, trust me. Okay, if you have attempted it, then you own the game actually. Okay, so let's okay, step marking. Let me just tell you, my dear, see, this is the main thing. This formula, this formula, if you have written, you will get 1 mark. Okay, formula, for this formula 1 mark. Okay, now this substitution, you can see the substitution I am doing here. Okay, before calculating the N2, that will give you 2 mark. Sorry, 1 more mark. Okay, 1 more mark. Okay, now after calculating all the things with answer, that will give you another 1 mark. Okay, this is the this is the what it calls step marking. Okay, I guess it is okay for you. Let's go ahead with the next problem. Okay, see, for this particular case, you have to just compare the equation. So this is Arrhenius equation definitely. So what do we know? Log K equals to log of A equal minus EA by 2.303 RT. This is my equation. And what they gave, let me write. Log K equals to 14.34 minus 1.25 into 10 power 4 by, okay, into K by T. So now if you compare these two equations, these two I can equate. Comparing equation 1 and 2, I can write EA by 2.303 RT is going to be equals to that value. 1.25 into 10 power 4 into K divided by T. Okay, so that's it. So now let's go ahead. Okay, so now what I can do here, so for this case, just find out the EA value in terms of this thing. So EA, if you just multiply this thing, you can see TT will be cancelled out. So you are going to get something 1.25 into 10 power 4 K into 2.303 R. Okay, up to this it is clear. Anyone is having any doubt, just let me know. Okay, so for this case now what I am going to do, we are going to substitute the value of all the things now. If you just substitute the value here, you will end up with the answer. The answer should come up to be something like, EA value will come up to be something like, 23939.75 joule per mole. Okay, this is your EA value will come up to be. Okay, I guess this is clear for you. Let's go ahead. Okay, this is a direct question. I don't think that I have to tell you this. Let's go ahead. Okay, for next question, let's see if I have to, what I have to find out. E0 cell, we can use the formula 0.059 divided by n into log K. So if you put the value over here, so your log K is going to be 0. What is given, 230 into 2, because n value is 2 for this case, divided by 0.059. So if you calculate this, your answer you should get it as log K value If you do your answer, you should get it as 7.7 something. So that is the answer. I guess that also you got correct. Let's go ahead. Let's go ahead. Okay, 7.7. Yes, very good. Okay, let's go. We will go back, don't worry. Whatever the doubt you are having in the MCQ, we will again go back to the MCQ. If you are having any doubt, I will explain. Don't worry. Let me just finish it off at first. Okay. So, let's go. 1 gram of a non-electrolyte. Again, this is a direct question. Okay. It is a direct question. Let me just directly write it. So, I am having the formula delta TF. Make sure that you are writing the proper formula, otherwise you will not get marks. Okay. W2 divided by M2 into W1, right? So, if you just go ahead with this, I will put the weight in kg itself, so I am not multiplying with 1000. If you want, you can do actually. Let me do it. Okay, fine. So, for this case, M2 will be something like, M2 if I take it here, Kf into W2 into 1000 divided by delta TF into W1, right? So, now if you just put the value 5.12 into how much gram they have given? 1 gram. 1 gram into 1000 divided by delta TF, how much they have given? 0.40 into this weight is how much? 50 gram. As you have multiplied already, you don't have to convert it into kg. So, whatever the thing, you will end up with gram per mole. Okay, wait, let me tell you the answer. You should get 256 out of calculation. Okay, you should get 256 out of the calculation. Okay, I guess it is clear. Just let me know if anyone got anything else out of it. Okay, I guess it's fine, all of you. Next, this is again, it's a common question actually. Let's go ahead with the problem. So basically you are having lambda M0 for CaCl2. Okay, is it the question you are asking that order of the reaction? That thing, order value cannot be infinity. But let me just go through the question once again. I will go back, don't worry. Okay, so lambda M0 of CaCl2 is given as 271.6 Simon centimeter square mole inverse. Okay, so now what is, if you just find it out, lambda M0 is basically lambda M0 of Ca2 lambda 0 of Ca2 plus 2 into lambda 0 of Cl minus. So now if you just put the value 271.6 and here this value you have to find out. So minus lambda 0 of Ca2 plus. Ca2 plus is given as 119.0 Simon centimeter square mole inverse, right, divided by 2. Right, divided by 2, that is basically equals to lambda of Cl minus. Okay, if you just calculate this, your value should be something 73.7 Simon centimeter square mole inverse. Okay, that is your lambda Cl minus, lambda 0 of Cl minus. Okay, I guess it is clear. Yeah, 73.76 like that only you will get. Okay, let's go ahead. wait, 76.3 I guess. Let me do it by myself, I will tell you. So basically if you just go ahead, it should be 76.3 I guess. Okay, 76.3. Okay, 152.6 you will get above by just eliminating the term divided by 2. Yeah, 76.3. Just let me know if you got it. Yeah, very good, 76.3. So yeah, let's go ahead. Okay, for 156, whoever got 156, for them, I guess you did not divide it with 2, right? So basically calcium chloride, if you just dissociate CaCl2, it will come up to be Ca2 plus 2Cl minus. So make sure you are dividing this with 2, otherwise the answer will not come. Because basically here minus, after doing the minus, you will get 156 something you are telling. Okay, so no, that particular case also the answer should be 10 gram only. I have calculated, this is a known problem, you know, you can get 0.25 mole here, 0.25 into 40, if you calculate, it will come up to be 40 gram only. You don't even need even calculator for this thing. Okay. So yeah, let's go ahead. Okay, I will go back to MCQ, 8th MCQ, and I will check the question once again. But I thought the order value they are asking, the value of the order means we are calling as second order, third order, fourth order, fifth order. Infinite order is not possible. That's what I'm telling. I will check the question once again. Okay, let's go ahead. Yeah, I guess this is okay. Okay, for this particular case, what you have to do? For this particular case, what you have to do? So 40 minutes for 30% decomposition, calculate the T half. So first you have to apply the first order equation and then you have to find the T half value. Okay, so let's go ahead accordingly. Okay, so basically if I do it, K is basically 2.303 divided by T, and here log of A by A minus X. Okay, so if I just put the thing here, 2.303, here I will get 40 minutes. Okay, log, here if I start with 1, then after 30% completion, it should be 0.7, right? So yeah, let's go ahead with this calculation. If you go ahead further, 1 by 0.7, so let me just do it. So 2.303 by 40, you will get log 1 by 0.7, means you should get something around 1.4, if I'm not wrong, 1.4. Okay, so let's further go ahead. 2.303 divided by 40 divided by 40, here log 1.4 value, right? It is 1.5 value, se thoda kam hoga. Okay, so your value should be something like 0.15, if I'm not wrong. Nearby to this, I'm just doing rough calculation, it should be 0.15 something. Okay, next if you just calculate the entire thing, let me just tell you the answer. You should get it something 0.00892 minute inverse. Okay, this is something you should get. After that, what you have to do? You have to calculate the T half. T half is basically 0.693 divided by K. K value if you put from here, that is 0.693 divided by 0.0089. Okay, so if you put this, you should end up with the answer. You should end up with the answer 77.6 or 77.7 something minute. Okay, 69 I guess. 77.69 minute will be your answer. Just let me know if you have done it correctly. Okay, 77.7 minute, it's correct. Okay, very good. I guess it is clear. Okay, so I guess there are no numerical. So let me just go back to the MCQ section and let me just check the question. Okay, so here equilibrium constant has no unit by. Okay, so you can just simply keep it like that, 7.7. That's it. Okay, so yeah, let's go ahead. We are going back actually, not ahead. MCQ 8th one, right? Let me just go through the question properly. Okay, this one. Okay, so the question is basically which of the following statement is incorrect about the order and molecularity of a chemical reaction. Okay, first the probability, it is going to be true by any means. Next, the values, that is definitely wrong. I guess for this case also you don't have any doubt. Okay, this is also correct one. Okay, now you have problem with this. There can be infinite number of values for orders. Okay, let me tell you, for a specific reaction, if you take a specific reaction, then order cannot be infinite number. How it can be infinite number for a specific reaction? Yes, for many reaction, if you have like order values can be anything. Order values, whatever the value of the order, it can be fractional, 0, minus, plus, everything. So with that perspective, you must be telling that, yeah, from 0 to there, you can get any value out of it. But for a specific reaction, how the number of values of order can be infinite? That you tell me. That's what I am also telling. Order of the reaction can be 0, positive, negative, fractional, everything. But for a specific reaction, we calculate the order, right? For a specific reaction only we calculate order. That you tell me, right? If you calculate the order for a specific reaction, then for a single reaction, how order can be infinite values? That you tell me at first. Definitely a reaction cannot have multiple rate determining step, right? So how order can be infinite? You tell me. Any doubt related to that? Pradyun was asking me this, I guess. Pradyun, can you please tell me? But antilog you don't have to do, don't worry. If you have done log KC, they are asking for log KC, they are not asking for KC. They are asking for log KC only. So you don't have to think about it. Okay, antilog you don't have to do. Okay, so I guess it is clear for you. 25, okay, let me just go back to 25. What is 25? Let me check once. (24). (25). Okay, 25. Okay, carbon, number of carbon I gave wrong. Yeah, fine. Let me check it. Let me just make it correct. One carbon less, right? Yeah, that's going to be one carbon less. That's okay. CH3, COCl. So if I just change the sign, I mean change the number of carbon, so that is also going to be same thing. Now I guess it is clear. Now I guess it is okay. Okay, I mistakenly gave one carbon extra. Now just tell me. Now just tell me if it is correct or not. Okay, octacarbonyl dicobalt 0, will I get dicobalt? Octacarbonyl, no, octacarbon, no, octacarbonyl, my dear. Octacarbon you will not get marks. Okay, I guess this is clear for you. Okay, so I guess there are no doubts. If you are having any doubts, that you ask me. For formula and substitution, for formula you will get 1 marks, for substitution you will get another 1 marks. Okay, 29th B. Okay, let me go back to 29th B. 29th B, 28, 29th B. This one, H2SO4, that's going to be H2SO4, right? Instead of dry HCl, I have written only HCl. Yeah, HCl gas means dry HCl basically. That's what I told. Okay, it's fine. Okay, so that's, yeah, if you write H plus, you should get marks. Okay, yes, H plus they will give you marks. Okay, yeah, 2H plus definitely you have to balance. I told you have to write the balanced equation always. Okay, so I guess you are not having any issues. So yes, if you got a little bit of faith now about the channel, not a little bit I guess. So if you have done my class properly, trust me guys, you would have got something 65 plus. Okay, 2 MCQ I got that I did not touch. Okay, so you should get 68 marks. So yes, our channel is trustworthy. You got the result in physics, and today chemistry again the thing is proved. So yes, like the video, subscribe the channel for your benefits, and share with your other friends so that they can also get the benefits. So yes, thank you so much. Thank you so much for your supporting. So that's gonna be the last live with you people. So yes, after that someone else will take over. So thank you so much. I really had a nice time with all of you people. Thank you so much. Yes, goodbye.